this video we're going to be going over the chi-squared test. So this is a test to determine if results are likely to be due to chance or not by comparing observed and expected results. So we're going to be comparing the chi-squared value to critical values from data booklets. So here we have chi-squared value. This is the summation. Observed frequency, expected frequency. To calculate expected frequency, it's row total multiplied by column total divided by overall total. In the case of genetic crosses, we can use Punnett square ratios to obtain the expected frequency, but that won't be used in this example. Degrees of freedom, so we need to calculate the degrees of freedom to look up on the data tables for the chi-squared. So if we do an example, we have hydrangea flowers. So we have pink and blue. If you don't know hydrangea flowers, they change colour depending on the acidity or basicity of the soil that they're in. So they'll go pink if they are basic, or blue if they're acidic. So to calculate we have got our observed values here, and we're going to calculate the expected values. So if we add the rows, because we need the row total, column total and overall total as mentioned by the equation up here. So we'll have 65 plus 13 gives you 78, 82 plus 7, 89, 65 plus 82, 147, and 13 plus 7, which is 20. So our expected values we're going to be calculating now are going to be in brackets, so it's easier to see. So incorporating this equation for pink acidic, we're going to do row total, so 78 multiplied by column total, 147, divided by overall total, which is 147 plus 20, so 167. And that will be the same if we added these two together to get the overall total. 167. So our expected value is 68.66. If we do that for the rest of the three boxes, so we have 78 multiplied by 20 over 167, 9.34, 89 multiplied by 147 divided by 167 is 78.34, and 89 multiplied by 20 divided by 167 to get 10.66. So the ones in brackets are our expected values. The ones in ballpoint pen are our observed values. So if we go on to the next page, you see we've got to do a null hypothesis and an alternative hypothesis because we're doing a statistical test. So for a chi-squared, the null hypothesis is that there is no significant difference between the colour of the flower and the pH of the soil. The alternative hypothesis will be that there is a significant difference. So the null hypothesis is notated by H subscript 0, alternative is H subscript 1. So here we have a table. We need observed values, which we had on the previous page, observed minus expected, and observed minus expected squared over expected. So we had our observed and expected results on the previous page. If I write them down here, column for expected, so we had 65 and 68.66, we had 13 and 9.34, 82 and 18.34, sorry, 78.34 I think, and 7 and 10.66. So I've just written them down on a piece of paper so I don't have to flip the piece of paper over again. Then we have to do the observed minus the expected squared, because in our equation we had observed minus expected squared, and then we divide by e and sum later. So observe minus expected, and then we square it to get a positive answer, 13.3956, and we do that all the way down. And surprisingly we have the same exact answer for all of them, and then we're going to divide them all by the expected result. So we have 13.3956, we'll store that as an answer because we have the same on here. So we'll have 13.3956 divided by 68.66, 0.1951, and we'll do the same for the next row, 9.34, and the next row, 78.34, 0.1710, and then 10.66, which gives us 1.2566. So now that we've got the values for this, we need to add them all up. That gives 3.0569. So our value for chi-squared is 3.0569. So what we do with this value, we've got to calculate the degrees of freedom first. The degrees of freedom if we have more than one row. So we have 2 rows and 2 columns. So to calculate degrees of freedom will be 2 minus 1 multiplied by 2 minus 1. So degrees of freedom equal 2 minus 1 multiplied by 2 minus 1, which is 1. And the critical value at 1 degree of freedom is 3.84 from the data tables. So because our chi-squared value is less than the critical value, we can write the conclusion. So the value of 3.0569, and once we've done a chi-squared test or any statistical test, we need to write a conclusion about what our test shows. So write the value of 3.0569 is smaller than the critical value of 3.84 at 0.05 probability. So this means there is a more than 5% chance that the differences are due to chance. The differences of the soil and the pH is in the colour of the flowers. So therefore we reject the alternative hypothesis because it means there's a more than 5% chance that the differences are due to chance, which means there's not a significant difference. So that's how you do a chi-squared test and write a conclusion.